Now we talked about these two obtuse angles, 121, LJP and KJN, and those are the only obtuse angles that there are in this graph here. So LJP and KJN. So angle, I'm going to say angle LJP. Good. All right, we are almost done. Last page. Now, if you are in my geometry class and you have this last page here, you can ignore this last page. You just do the homework that you're assigned. Okay. Now we're going to talk about congruent angles. Okay, congruent angles. Angle. Let's actually start with the diagram that we're going to use. I've got a line here. I've got a point A and a point B. And then I have a point over here, point E and point F. From B, I should say, has an array that's coming out. And this is going to be point C along that ray. And then at point E, I have a ray that's coming from there, and I'm going to have a point D on that ray. Okay, so angle ABC is 65 degrees. And angle DEF is also 65 degrees. So I can say that angle ABC is congruent to angle FED. ABC, FED. I can also say, and the way we say these are congruent is I draw a line or an arc here and an arc here, and that says this angle is congruent to this angle. Now on this diagram, there are two other angles that are congruent to one another, and those are angle CBE, and DEB. Oh, sorry, DEB. Isn't that what I said? DEB. Now, these are congruent because if I subtract 65 from 180, then I get this, which is 115. And I do the same thing over here, 65 from 180, 115. So that means this angle is congruent to this angle. And notice how one angle is congruent to another one, and those I use one arc. And then I have other angles that are congruent to one another on the same diagram, then I use two arcs. And then if I had more angles that were congruent to one another on this diagram, then I would use three arcs, and then four arcs, and so on and so forth. One other thing we're going to look at before we do a couple examples is an angle bisector. An angle bisector is when I have an angle and I have a ray or a line or a segment or something that cuts this angle in half so that this angle is congruent to this angle. And so let's put some points on here. So this is X out here, my vertex is Y, and then I've got Z over here, and then let's do this angle bisector here will be YW, ray YW. So let's talk about this, let's write something about this. So I've got angle XYZ. We're going to say this is angle XYZ, and we're going to say that's 160 degrees. We're just going to say it is. I don't know what it is, but we'll just say it's 160 degrees. So that means if this ray YW cuts this angle in half, then XYW, angle XYW, that's this one here, is going to be half of 160, which is 80 degrees. And likewise, WYZ will also be 80 degrees. And angle XYW is going to be congruent to, as we've drawn here, congruent to angle WYZ. So when you cut something in half, you cut it in two equal parts. So if this ray cut this angle in half, then this angle that's left over here is going to be the same size as this angle over here because it was cut in half. So this one is congruent to this one, and that's what we're saying here. Okay, now let's do an example here together. We're going to draw a line, and then about in the middle of the line is point K, toward the top is M, toward the bottom is J. Now coming out of K, I've got a ray this way and a ray this way. That's not drawn to scale. All right, this is L, this point over here is N, and that's it. Okay, now we know a couple other things about this, and that is we have this angle congruent to this angle. It might not look like it, but these are congruent angles here. Now this angle NKL is 6x plus 11 degrees. And this angle here, NKJ, is 8x minus 13 degrees. So let's talk about this before we start doing anything with it. So Kn, ray Kn bisects, so Kn here bisects this angle LKJ. Okay, so we know that cuts it right in half. And so we know that these two angles are congruent. So we are going to try to find measure of angle JKN. And we're going to try to find the measure of angle LKJ. Let's see how we can do this. So I think I'm going to do this one, and then you can do this one. Okay. JKN. JKN. So that's this angle here. I want to find the measure of this angle. And I know that this angle, LKN, is congruent to this one. So what all I need to do here is set these two equal to one another because the angles are congruent. So I can say that these two values are equal to one another because they are. And so now I can just do some algebra to find out what x equals. So I'm going to subtract 6x from each side, and I get 11 equals 2x minus 13. Then I add 13 to each side. What I do to one side, I do to the other side. And I get 24 equals 2x. Divide by 2 from both sides. 12 equals x. Yay, 12 equals x. Am I done? No, I'm not done. I found what x is, but I want to find this angle. So, and that is angle JKN. All right, JKN, that's this one. So all I need to do now is I substitute this value for x into 8x minus 13. So I say 8 times x, which is 12, minus 13 is going to give me JKN. So 8 times 12 is 98. Is that right? 89, oh, 96, right? 96. So this is 96 minus 13. 96 minus 13 is 83. So I've got 83 degrees for JKN. Now, how do I use that information to find out what LKJ is? So LKJ, that's this whole thing. Okay, pause and try to figure it out. Did you say 83 is this measurement, and so this measurement here for this angle also is 83, and so you just say, I need this whole thing together, 83 plus 83 equals 166. That is your answer, 166. And that is the end of the long lesson 1-4.